Security visualization. Why would you visualize for security? What's some of the reasons? Well, there are multiple reasons. One is just to explore and discover. Sometimes these visualizations are going to answer questions. Other times they will bring up new questions. If you look at this graph, you probably have a lot of questions. They help you making decisions. They give you a situational overview of what's going on. Sometimes graphs or visualizations just inspire. And sometimes they're just fun. So let's look at these examples that are tools that visualize security data. Here you see a graph of IRC data. Make up your own mind. What do you see? What can you read from this? What does it tell us? Looks complicated. This is a parallel coordinate graph, completely jammed. I can't tell you what's going on here. It looks pretty complicated. This is a three-dimensional view. Looks interesting. The colors probably don't get quite across in this beamer here, but I think you get the idea. Let's look at some simpler charts. What else can go wrong? This here is a huge table of SAP T codes. This table shows if there are conflicts in separation of duties. It's a pretty big table. I think there are about 15 of those tables. This is a bar chart that starts at 3 on the y-axis if you look there. So the areas are completely out of relation. They don't really tell us much. This one is even worse. There's 2 categorical dimensions mapped onto a bar chart. This doesn't tell us anything at all. The bars are completely deceiving. Information overload, clearly. I can't even read the labels. Well, 3D is probably the answer, right? More dimensions, 3 dimensions, more data. Think about what happens if one of those back bars is actually smaller than the ones in the front. You're going to lose. You're not going to see what it is. So 3D is not always the solution. This one here, I might see some trend on the left side with all these data points, but there's occlusion happening here. The labels start overlapping. I can't really read what the values are. So probably not the solution. Everybody loves pie charts. Some people go over the top with pie charts, stacked pie charts. It takes you a while to read this, probably. It has 2 dimensions of data in there. This is a horrible example I found in the security tool. Do you see that glare? That's not data. That's just visual clutter. It's just a flare, a lens flare on it. It doesn't encode any information. Pie charts on here, the labels are the percentages, but what are those individual sectors really? You have to go back to the legend. Why not using a bar chart? Dashboards, you all have seen dashboards probably. 3-dimensional pie charts, even better than just 2D, right? Gradients used. Another great pie chart here, I love this one. All the slices seem to be the same size, but are they really? What happens if there are small variances? You won't be able to see that. What about specific security tools, things that have been written to visualize security data? This one here, one example, I don't think you can actually see there's red in there. This is an example that visualizes network traffic. Okay, so what? What does it show me? What does this here tell me? You need to read the paper to understand this, and the paper is an academic paper. It's great. This one here poses a lot of questions. I want to start drilling down. I want to investigate what are these values, what are those nodes, what's the traffic below that. I don't have to say anything about this one. Here, a three-dimensional example. Network topology is mapped. Can you show me the trends? Here, a nicely rendered US map or America's map. What are those bars in the back on the horizon? I don't even know where they're located. Well, maybe adding some lines that connect all the different locations. What happens if there's a lot of traffic? Are you going to see the map even? Here's made /.news, GL tail. I looked at it, it looks great visually, but my question was, so what? What does it show me? So let's look at the New York Times. A lot of you probably read some newspaper, the New York Times. If you look through some of the charts, they're simple. They have legends. There's a lot of text in there. You can read what's going on. Here's another example of a line chart with a lot of descriptions, what's actually shown. There are labels on the axis. Here, they use two charts to show a certain property or go into details of one of those bars on the left-hand side to give you more detail. This is just a table with some bar charts in them, not pie charts, bars. You can actually compare these things. Here you see a map, and again augmented with some bar charts that actually show the details of the values. Here another line chart, here 6 line charts. Sometimes one chart just doesn't cut it. You could overlay all these lines in one. Again, tables, very simple tables, a very simple line chart. Note that 4.9% of the top right, it actually shows what the value is currently, highlighting some of the values. The New York Times also uses more complicated charts, like scatter plots or sector charts. So look at this one. It looks fairly complicated, but it's very visually simple. They help you with the legend right there. They label the quadrants. What does it mean for something to be on top right? What does it mean for something to be on bottom left? Again, there's text that describes things. Here you see what happens if the MSN and Yahoo merger, something moves over to the right. So there's movement, there's change encoded in this graph. And again, there's text describing what's going on. They're very, very creative at the New York Times. If you look at some of the charts they do, they have a timeline here, and sometimes they even get the news right, not just the graphs. This one, very creative. They map the words that different politicians were using during their speeches. Here, Democrats versus Republicans. The circles, the size encodes how many times this word was mentioned in a speech. Very creative. Another example here, where they break it down by people. On the bottom, you see a summary of all the terms mentioned. Again, in the table, you encode with different bubble sizes, so you see right away what was the most used word, what's the distribution among the people of these words. Or here, maps. They use a lot of maps. There's a lot of information you can encode. But again, there is a legend for this. You can't see it right now. But then also, there's annotations. What is this area here about? There's text that describes what's going on. Or this here, it's, to read this, it takes you a while. You need to know what the colors mean. This is a tree map example. But they don't shy back from using these more complicated things. So with this, I'm going to end this little overview video, and I'm going to switch over to my presentation. Oh, great. Hello. I can't use a Mac. They gave me a Mac at work, and I was like, what am I doing with this? So you can tell I still don't know how to use it. Sorry for this. Here we go. I think Frank is probably hacking my laptop right now, wirelessly, somehow, Bluetooth or something. See if I click here, nothing happens. Maybe. I always thought Macs were so seamless and everything just worked, but I guess that's not the case. Come on here. All right. There we go. All right, sorry. So I titled this talk, All the Data That's Fit to Visualize, to kind of imitate the New York Times slogan. And I want to show you what the New York Times can teach us about visualization or security visualization in general. The first thing I want to say is I think we need better security visualization. And this is kind of contrary to what I usually preach up here if I speak at conferences. Usually I'm like, look, this is security visualization, this is how you do it, these are some of the things you should do. But I want to question some of the things that have been done in the past. And one of the problems I see with security visualization is that there's really two fields out there. One is security, that's all of us, all of you guys. And then there's visualization. And I don't think any of us in here has probably a degree in visualization or in arts or anything like that. And that's a problem because what happens is that security researchers, they go ahead and they start building visualization tools. Well, they don't know anything about human perception, of human computer interface design, of depth queue theories, of color theory, you name it. And usually it goes wrong. The same is true for visualization people, right? I read papers for conferences, and the visualization people submit something for security visualization. They just get security wrong. They get networking wrong. I could name some examples of things I read in papers, and it's just horrible. So what needs to happen really is we need to merge this field, or these two fields together into one field. And we need to make sure that people get educations on both sides. So this is going to be a crash course in visualization for you guys. And I'm going to show you some of the things that are fairly simple to learn. So we need to educate or build this security visualization community. And if you go to secvis.org, it's the first attempt of a little portal that I built where people can share information about visualization, about security visualization specifically, and exchange themselves, exchange graphs, and so on. I'm also working on a book right now that's hopefully out by Black Hat on applied security visualization, where I talk a little more in depth about these things and how do you practically go about visualizing some of this data. And then there's Greg Conti's book that I contributed 2 chapters to that's talking about security visualization as well. So there is a starting point. So why do I take the New York Times, and how did I even come up with this idea of going to the New York Times and trying to learn about visualization? I don't really read the newspaper ever, but some Sunday, for some reason, I picked up the New York Times and looked through it, and I'm like, interesting charts. Some of them were just a simple bar charts or line charts, and then I saw some sector charts, and there's some more complicated things. I'm like, this looks interesting. So I started investigating a little bit, tried to find some literature about it, didn't find anything. And then just recently I came about a blog post and I came across a keynote that the director of the graphics department gave at Infoviz last year, a conference that's held yearly. So I looked through that and did some more research, and I found that the New York Times actually has a very sophisticated graphics department. And so here are some of the things that they do, or some of the principles that they put forward. One of the biggest things, or kind of paradigms they have, is show, don't tell. So make sure that you embed textual descriptions, and I mentioned this earlier, into your graphs. If you look on the right side, there's a lot of text there. There's not just graphs. Combine different types of visualization. So you see the map, you see the bar charts that augment the data and give you more detail on it. And if you have ever been to the New York Times website, play around there, and there's a lot of interactive visualizations, very, very interesting. They have great Flash design. I think it's Flash that they use for different purposes where they really, really nicely, interactively let you play with the data. There's, for example, I think there's certain market data like on oil, on the oil industry, you can browse all the stock prices and what happened. You can play with the axes and see what's going on over time. Really, really nice. And the last point is honest portrayal, and I found this as one of the paradigms that they put forward, and I thought it was very interesting, right? Journalists are not necessarily always the most honest ones, but I think it's actually pretty good that they put this under one of their principles. They have a pipeline. How do they go about building these graphs? The first step in there is find. So do research, find the data that you want to look at, and this directly translates into a security example, right? If you want to generate some graphs, go out, find all the information you need, collect as much as you can about it, look at different data sources, then try to explain what's going on. Look at the data, get some idea of what's going on, try to figure out what are the displays you could be using. Go ahead and annotate the things that you build. So as I stressed already a few times, to guide the user through the data, to explain what the data is about. And then go about designing these things. So now you have the chart, you might decide to use a bar chart. Well, how do you use color now? How do you use like patterns in there, or do you have to use all those things? Do you need a box around your bar charts, and so on? And then go on and edit. This is an iterative process. Go back. Maybe you need more data because something might not make sense, or you might have to verify the data you have. So go around on this pipeline. So here are some examples. What's the right visual to use? What's the right type of graph to use to visualize some information? Well, sometimes it's just a simple table. Sometimes the table is the best way to bring data across or to communicate data. You can use some highlighting here with like a nice gray bar on the data set you want to highlight. Note that there's no grid lines in here. However, you can read this table just perfectly fine. Here's a little more complicated example where in the third column you have a little graphical indicator of one of the values. Very simple. This is not rocket science. So use adequate graphs instead of the top right one that I showed earlier. Well, maybe there's 3 charts that you need that explain the data, and the one on the top right obviously is not the right chart to use. Sometimes a simple chart is just a simple chart. Be creative. Don't be scared to use some more complicated things. So on the back there, you see a tree map. Tree maps are great to encode multidimensional data, not just like if you have multiple things you have in a data set. For example, if you look at a log file of network traffic, then each of the fields you can think of as a dimension, the source address, the destination address, the ports. They're great to encode multiple dimensions. You can use color to encode certain properties in there so that different tiles jump right out at you when you look at that. The bottom right, I'm going to show a little more detail in a second. It's a sector chart from the New York Times. When you design these graphs, keep Tufte in the back of your head. Tufte is, Edward Tufte is one of the probably most famous people in visualization right now. He gives classes and he has written 4 books on just information visualization. His books are awesome to read. They're really, really very well done. Amazing visualizations he has in there. He has a lot of history also about visualization. If you're serious about visualizing things, at least go to a library or to the bookstore and look through the books. They inspire a lot. One of the things that Tufte preaches is that you should reduce the data ink ratio. What does that mean? Well, if you look at if you have to print on a printer a certain graph, there's a certain amount of ink you use. Every drop of ink that you need to plot or to print non-data on that graph is wasted. So you should only use ink to actually print part or to illustrate the data. So on the right-hand side bar chart, the grid lines are even superfluous. You don't need the grid lines really. But here they're just very fine gray lines. It's probably fine. But note, there are no like boxes around this bar chart. There's no background with like a gradient or a super cool picture in the back that just distracts from the data. It's very simple gray, black charts. If you draw bar charts, please start with 0 at the y-axis, because otherwise the areas inside of the bars don't make sense anymore. They're not relational. The areas they don't show the relative values anymore, so you can't compare. If I have a bar that's 5 times as high as another one, if you start at 0, that really means it's 5 times as much. But if you start at 5, it's not true anymore. So be careful with that. And you find a lot of charts that don't do that, are very misleading. Here's just another example. Sometimes you don't even need a legend or a y-axis that actually shows you the exact values. Here it's really just about the development, about how proportionally higher it is on the right side. On the left side you were actually behind. On the right it's very far ahead. Note also that on the bottom there's the actual data is emphasized in a table and summarized again, so it helps the graph. So don't use those pie charts with lens flares and whatnots and that are very misleading, but use very simple charts that and think of the data ink ratio. Look through the Tufte books and look at some other design principles that he has. Complicated visualization. So what I already kind of mentioned before, this is it's a pretty bad scan, but I took a whole issue of the New York Times and scanned all the graphs in, so these are some of them. This is a fairly complicated chart. The data is something that everyone is very familiar with. It's temperature data. You'll find this chart in every issue of the New York Times, so people can read this. Although it looks a little complicated, it probably takes you a couple minutes to understand what's really going on. People understand this, so your audience is actually fairly smart. Don't assume that you need to use very simple things. Stock charts. People can read these things. It took me a while to understand what the heck is going on here, but I think I have somewhat of a grip now. I guess the easiest to read is just part of it. It's that very spiky line here that goes up and then falls down again. So these are just the stock prices over a day. They use little box plots there to show the maximum and the minimum. Coded in here, and it's fairly complex to actually read all of this. But again, people are smart. They can read this. Sector charts. This was really what caught my eye when I looked through the New York Times. This it looks like a scatter plot. There's a lot of information encoded in here. This basically shows how well a over time. And very interestingly, right below this chart, there's a description on how to read this. So you don't have to go and analyze all this and figure it out yourself, but there's a description here. So there's the white dot in the middle where the axes cross. That's the S&P 500 index. So if you're familiar with stocks and so on, it's just an index that a lot of stocks are tracked against to see whether they do better than the S&P 500 or worse. So now if a dot is on the top right, it's actually a leading stock, meaning that over the last week, it was going up, and it already was going up over the last year. So this stock is continuing to do better. On the bottom right, for example, it was up this week, but really it was down over the last year. So that's an improving stock, and so on. Then on the bottom left, you see the size of these circles is the market capitalization of this stock at the moment. So now if we look at this chart again, it might make a little more sense. So the top right stock there over here has a low market capitalization. It's not very big, this circle. However, it's a leading stock. It has been doing well over the last week and over the last year already. And the higher up it is, the better it has been doing. This is there's a lot of information in here. It's fairly complex to read, but again, people understand this. So I was thinking about this a little bit, and I was trying to apply this sector chart to computer security. And I'm not sure how much this is really telling you, and I see Dan Geary there in the back, and he might have some comments about this later. So what I was trying to do is say, well, let's look at some risk metric. And I don't know how I would track my risk in my company, but you probably can come up with some metric that you want to track that might be very simplistic, just looking at the number of blocks you had on your firewall over a day, or you can go more complicated. You can use any kind of metric to try to map that in here. So what I did here is I said, well, let me look at the change of this metric, whatever I choose, over the last day and over the last week. So very analogous to what we just saw before. And I'm going to do this per department. So the colors here, the different bubbles are different departments. The size of this bubble encodes the current risk value. So the bigger, the higher the risk. Now what happens, I see the change. So the higher on the top right you are, the worse. And actually indicating that with the two arrows there, so you understand what's going on. You see that, for example, the finance department, that's the gray bubble here, had no change over the last week or the last day in risk, so there was nothing being done there. Maybe they're just lazy, finance people. Then legal has a fairly high risk, so it's a little bigger, the circle. Over the last day, it has decreased in risk. Over the last week, it has stayed the same. So there's a lot of information here, and you could use this as maybe a daily or a weekly chart that you can go look at and say, oh, the one on the top right, I might have to focus on. It has been going down, or the risk has increased in that department. And you can look at the size of the bubble to figure out whether it's actually, the risk is really high, or it just has gone up and it's still fairly small. So I'll take comments on this. If anyone has any, you can do it in the end also. Right now everyone is quiet, all right. Another interesting method of visualizing data are Sparklines. I guess I never really understood them until I took Tufte's class about 2 months ago. I thought, well, I'm writing a book about visualization. I should probably take the class at some point. And I read his books already. I was like, well, I'm not going to learn much, but I was very inspired, I have to say. And I think I finally understood what he was doing. So these Sparklines encode an amazing amount of data on a very small space. What you see here is I took a firewall log file, and I looked at 3 fields in there: the source address, the destination address, and the destination port. I looked at this firewall log in a lot of different ways, and I found some things, and I looked at some link graphs that show me the connections between machines and so on. It's all fairly interesting. And then I said, well, let's try this with these Sparklines. And I plotted them. I found a plugin for Excel. I'm happy to let you guys know where to find this. It's free. It's not super good. It works. So what you see here, let's look at one of these to quickly understand what's going on. So on the top left here, you see a red line in each of these little Sparklines. You might not see the red really, but there's one line that shows the average over all of the values. And then the gray band is the first standard deviation. So it basically shows kind of the normal behavior of one of these values here. So one thing to look at is as soon as the line breaks out of this gray band, there might be an anomaly. There's more going on in that area right now than there might have to be. On the x-axis, you see basically every day I take a count of how many blocks I found for that machine. So now, again, you can look at outliers out of the gray band. But you can also just look at the different shapes. And this was most amazing to me, that there's a lot of shapes that are very similar. One of them is down here. This multicast address is exactly the same shape as this 427 port. And I went actually back to the log file, and it was exactly that way, right? That a lot of multicast traffic is using the service discovery port. Makes sense, right? Because the service discovery actually uses multicast addresses, so that's inherent to that protocol to do this. So right away, I saw this, and I was able to filter that out. I know, well, this is probably fine. I don't really need to care about it. It might be a misconfiguration that I might want to go back and figure out which hosts are doing this and fix them. But I also see others. For example, this source here, this destination, maybe this destination, maybe even this one with the spikes in the middle. They all seem to show similar behavior here. So I can make correlations and figure out, oh, these sources probably use these ports, and there's similar behavior in here, and what does that really mean? So port 53 is always used when there is port 80 used, and note that the height of these individual spikes is not related to each other. So each sparkline has different y-axis, right? There's a different scale. So it doesn't mean that there's as much port 53 traffic as there is port 80 traffic. It just shows that there was a spike in general. But that might make sense, right? Because if you use HTTP, if you access a website, well, there's probably a DNS request that goes along with it. So I'm expecting this kind of behavior. Same for SMTP. So if I send a mail, there's probably a lookup on the MX record that goes along with that. So that might make sense. And then I can look, I might actually find my web servers in my network and my mail servers. So there's a lot of information encoded in here, and you can go down, you can start filtering things, see what happens then. Maybe there's new patterns showing up. So this is a very, very powerful tool. So instead of using three-dimensional charts, you can barely see this on the top right, but instead of using a three-dimensional chart, use multivariate graphs. That's one of my favorite words, multivariate. It basically just means that you can put multiple dimensions or multiple fields from a data set into the same graph. So things like parallel coordinates. You see an example down here. Again, not a very good picture on the screen here. But basically in parallel coordinates, what you do is you have multiple vertical lines, and each of the lines is a data dimension. So for example, here, on the left side here, I plot all of my source IP addresses from 0 to 255, 255, 255, 255. And then you might have the source and destination address, and then the ports from 0 to 65,535. And if you see an event going from IP address 0 to IP address 255, 255, 255, 255 on port 65,000, then you connect those dots. And now you plot all the data you have in this one graph, and you get patterns like the one on the bottom, so you might see trends right away. You can start filtering things and so on. So you have a lot of different dimensions in one graph, but again, it's not a three-dimensional complicated chart that you have to start interacting with and turning around and flying around and figuring out where you were before, and there's occlusion happening and so on. Tree maps, similar to that, where you have you can plot a lot of data on a small space. Sector charts, unfortunately, I wasn't able to find any literature on sector charts, and maybe a little more description on how they were used and so on. If anyone has any pointers, I'm not even sure if it's a real chart that is documented. I think it's probably something that the New York Times just came up with them by themselves. Sparklines, as you just saw, it's a lot of data on a very small space. And if you can, make these graphs interactive. If you have any possibility to do that, again, go to the New York Times website. There's other examples also, but I was really impressed with how well they have done this for different examples where you can interact with the data and explore the data. Well, from here, now what? Well, learn about visualization. I hope this inspired you a little bit and gave you some information on how to draw, quote, nice graphs and meaningful or graphs that actually communicate information very simply. Steal from other disciplines. I think I'm going to refer to Dan again. He comes from a biology background. He's trying to apply a lot of those analogies or those theories to computer security. So go out and steal from others. I stole from the New York Times. I mean, go out, find out where are the parallels from other disciplines, be that in visualization or in any other way. But let's try to learn from the others. They're smart people in other fields also. Try to apply these principles I showed you. They're very simple. Start the bar charts at 0, don't use any visual clutter. Be creative. Again, people that are reading your charts are not dumb. They're fairly smart and they can read more complicated charts also. Don't go over the top. Help them read your graphs, but don't assume that they can't read them. And then last but not least, share what you're doing with others so other people can pick that up. And one way to share your experiences on security visualization is you go to secvis.org. There's already a lot of people that discuss security visualization. Submit your graphs there and see what other people have to say. Maybe someone has a better method of visualizing your data. Maybe you find someone else that has done something in your area and you can steal from him and use those methods. Oh, that's nice. It's my keynote skills. That should have been one slide. But that's what I have. If you guys have questions, I'm happy to take any.
You could use this other mic for a little while over there and bring mine up too for that. Any other questions? No questions. Up. A live one over here.
I was just wondering if you had any input or advice on any tools that implement any of these types of things, specifically in the security space.
Yeah, are there any tools? I'm very disappointed. That's why I'm also saying we need better security visualization. In the space of security visualization specifically, there's barely anything. There's, I know, a big project at PNNL, which is Starlight, which is not free at all. You have to buy it. I think you can buy it commercially, but it's something that the government is using to mainly look at social networks and terrorist data and news data and so on. It's fairly powerful, but again, it's probably too expensive to get your hands on. Otherwise, there's not really many tools that do specifically security visualization. There's a couple that look at network traffic. That's probably where it really ends already, unfortunately, because security visualization really takes into account any kind of data that you have, be that operating system log files or web logs or you name it. Having said that, there's some open source tools that you can use to just graph data, and a lot of the things I do, I use either charting libraries or some of the tools out there, and especially for link graph visualization, so nodes and edges that are connected. There's quite a few tools out there. CAIDA is one of the things. If you go to caida.org, CAIDA, they do a lot of large-scale network traffic analysis, and they have some libraries that they posted. One is Walrus. There's a couple of others that they have. The problem with most of those libraries is that they require some proprietary data input, so you need to transform your data into some weird format. For Walrus especially, you need to compute your spanning tree by yourself. So the hurdles are they put hurdles in your way to actually get visualizations done. And plug in my book, I'm going to have a chapter on open source tools that you can use to visualize data. But again, specifically for security visualization, hopefully someone is going to come up with something. And if anyone knows some good tools, please let me know.
When you were fiddling with the Sparklines, were implying visually making clustering, with your own mind, just sort of pointing out on the screen, clustering kind of stuff. Is that something that you think is a direction that people should work on, the ability to visually cluster things? That's, I got that that's what you were trying to do. Was that illustrative, or do you think that's got a real value to it?
I think absolutely. The problem is, right, you have 100,000 lines of logs that you can put in here, and then you need to get a handle on it. You need to know just approximately what's going on. So you need to start filtering things. You need to figure out what's the parts in this log file that are of interest. By looking at this, you get an overview of what's going on. You get an idea of what's happening. And if you were able to actually even interact with these things and start interactively filtering out stuff and see what happens if you take certain parts out, or even go back to the original log entries and say, well, show me exactly what this spike is here, so you can draw the exact information and start eliminating clusters.
So, as a term of art, you're using this as exploratory data analysis, in effect. That's the idea behind the top-level kind of display that you're advocating.
Yes, exploratory, and maybe even to communicate information, right? If I need to give a report to someone and say, look, your machine generated way too much traffic here, it's the only one that spikes, there must be something wrong.
I'll post something to your site, but have you ever seen Chernof's faces? Herman Chernof, a guy who was at Harvard, he did a very clever thing. Multivariate data, one variable would be normalized, and that would be the width of the mouth in the subsequent stick drawing picture. Another variable would be normalized, and that would be the slant of the eyes, and so forth. And the point of his idea about that was for clustering, for visual clustering, that we as people are exceptionally good at facial recognition. So if we could draw faces, we might say, well, all these folks look like they're the same kind of people. And he would go with that. It was actually quite stunning. I'll post the reference to that. But
great,
if what you're after, and that's the reason for my question, if what you're after is some sort of exploratory clustering kind of display that says, here's something I should look at in, as you suggest, 100,000 lines of log or whatever it is that you can't possibly read.
Absolutely. I've seen the faces, actually, now that you mention them. They're fun. First I was like...
Well, they're completely fun. I mean, they're stick drawings.
Exactly.
Any 5-year-old would be able to look at... Well, that was actually Chernof's point. Any 5-year-old could look at this.
Right. I wonder how precise they can go. Like, what's the granularity that can actually go into it?
I don't know.
That's going to be interesting.
That's those problems left for the reader, or
Exactly, right.
that we've all seen.
Any other questions? One last one, we should probably wrap up.
Do you have any comment on the difference between representing something that's static and representing something that's dynamic? Like the difference between traffic analysis, which is something that's moving and changing, and the difference like the output of a large vulnerability scan, and trying to sort through that?
Well, animation can be another way of encoding information, right? Be that along the time axis, or if you're crazy, you can even go along some other axis. You could animate along the ports, for example. It takes a little bit of a mind game to do that, but it's possible. So having said that, you can also take time series data, so network traffic over time, and map that back into a static display that's not animated anymore. So what you're doing is you're basically taking away one dimension of display, which might increase the amount of data you put into these static images and might start to clutter them. So here, this is all time series data. You put everything on one display, and it might clutter it. If I was able to animate this over time, that would probably be very interesting, because I might see trends, I might see developments over time. So if you can animate it, definitely try to do that. It's probably a very powerful tool to look at the data. But again, unfortunately, the tools are missing. I don't know of any tool that helps you animate this kind of traffic in different types of visualizations. You can replay that in a TCP dump, but or I think Shoki, the packet hustler, is a 3-dimensional visualization that someone put together about 5 years ago. You have to patch your GCC compiler, I think, to actually even compile it nowadays. But it basically, it visualizes the network traffic in a 3-dimensional cube. And I think you can actually replay it in there. But again, the question is, how useful is it in the end? And I would like to use some other visualization methods along with that replay. All right. Okay, thank you very much.